اهلا بيكم مره تانية في كايرو دار my dear student of the third secondary stages. بنكمل رحلتنا النهارده with the calculus again، وكنا توقفنا قبل كده في رحلتنا مع الكالكولس مع دروس الامبليسيت فانكشن والهاي ديريفاتيف والجيومتريك ابلكيشن. هنخش النهارده مع بعضينا على درس مهم جدا. It's very important lesson as they said, the calculus. And this is related time rate. What do we mean by the word or the title related time rate? As we know that in the previous lessons of the differentiation, we differentiate the function contains symbol x or y according to the symbol x. As we know, dy over dx means the first derivative, or d2y over dx squared is the second derivative of the function y according to the symbol or the variable x. Now, if we have f of x equals y, we need to differentiate y now to the time t, which will be dy over dt. dy over dt means dy over dx, as we usually do, dot or multiply dx over dt. So we use here the form of chain rule to classify the meaning of dy over dt. So, for example, if we have y equals 3x to the power of 4, so if we differentiate the function dy over dt equals 4 times 3 equals 12x to the power of 3. Don't forget to write dx over dt also. Another example, if we have y equals sine x, so dy over dt equals cosine x multiplied by dx over dt. By the way, we have to remember that if we differentiate the function y according to the x or dy over dx, it will be cosine x only, and this term, which is dx over dt, will not be exist. Another example, if we have y equals 3x plus 2x power 3 all to the power of 7, then dy over dt will be, this is a differentiation of or derivative for the bracket, so it will be 7 3x plus 2x power 3 all to the power of 6 multiply 3 plus 6x power 2 multiply dx over dt. Don't forget to put this dy over dt. If we have another example, a particle moves along the curve x squared plus y squared plus 4x minus 6y plus 3 equals 0, and the rate of a change of its x coordinate equals 3 at the point one and 2, find the rate of a change of its y coordinate. Type. This is the solution. First, we have the equation of the curve x squared plus y squared plus 4x minus 6y plus 3 equals 0, and we have point 1 and 2. This is the point, and he said that the rate of a change of its x coordinate, that means dx over dt equals 3. So we are going to solve it now. X squared again plus y squared plus 4x minus 6y plus 3 equals 0. To differentiate to the time, now we have 2x dx over dt plus 2y dy over dt plus 4 dx over dt minus 6 dy over dt equals 0. We have to make a substitution, so 2 times 1 dx over dt, which is equal to 3, plus 2 y is 2, dy over dt unknown, plus 4 dx over dt, which is 3, minus 6 dy over dt equals 0. Now we have to collect 4 dy over dt minus 6 dy over dt. We have negative 2 dy over dt. 2 times 1 times 3 equals 6. 6 plus 12 is 18. Move 18 to the other side, will be negative 18. By dividing by negative 2, we will get the value of dy over dt equals 9. And this is the answer of the question what is the rate of a change in its y coordinate. Let's move directly to discuss with another example. We have the side, this is story problem, the side of cube increases at a rate or at the rate of 0.02 centimeter per second. Okay. While its surface increases at the rate of 0.08 centimeter square per second. Okay, find the length of the cube side at this instant. Which instant? The instant which the both of the length of the cube and its surface have the same increases rate. At this instant, and also find the rate of a change of its volume. It's a good problem. Let's move to solve it together. The side length of the cube, يبقى let the side length of cube equals x. We have dx over dt equals 0.02, and we have ds, s is the surface area of the cube, ds over dt equals 0.08. So let's move to find the relation. We know that surface area of the cube equals 6 x square differentiate to the time, ds over dt equals 12 x dx over dt. By substitute, instead of s and ds and ds over dt and dx over dt, we will find that 0.08 equals 12 x times 0.02. By dividing by 0.08, we get 12x equals 4, then x will be 1 over 3 centimeter, and this is the length of the cube when its length increases at a rate 0.02 per second, and in the same instant the increasing or the rate of changing on its surface area will be 0.08. That was the first request. The second request was find the rate of change of its volume at the same instant. Then we have to write the volume of the cube equals x to the power of 3, then dv over dt equals 3 x to the power of 2 dx over dt. That leads us to substitute 1 over 3, this is x, which we obtained from the first request, multiply dx over dt, which is 0.002, so it will be 1 over 150 centimeter cube per second, and this is the answer. Let's move now to very important problem. We will write it together, it's too long problem. In an instant, in an instant, the length of two sides of a right angled triangle, of a right angled triangle are 12 and 16 centimeters. Okay, if the length of first side increases at the rate two centimeter per second, and the length of the second side decreases at the rate one centimeter per second. Find the rate of a change of what? Of its surface area امتى بقى؟ after 2 seconds. After 2 seconds امتى؟ from the fixed instant. From the fixed instant. Now we have to see the solution. First, if we have right angle triangle like that, okay, first at instant. Do you know that this is the first position and this is the second position, because one of this part increases like that and the other will decreases like that. Okay, let's name it. This is D, C, and the main points A, B, and make it H. Okay, let's know that DB, DB. By the way, we can assume that this part increases like that or decreases like that. Also, if this part decreases or increases, that means one of them will be increasing and the other will be decreases according to the dimension of motion of the third side. Okay, so let's say that now dB equals 12 centimeter plus 2t. This is the part will be increased, so the motion now will be decreased here, which is pH, because we deal with this triangle now. So dH equals 16 minus t. Okay, what about surface area? Surface area equals half times base times height. This is half times base, which is yes, 16 minus t times 12 plus 2t. By simplifying, we will get that S equals 96 plus 10t minus t squared. Now we have to differentiate to the time. ds over dt equals 10 minus 2t. After 2 seconds means at t equals 2, that means ds over dt equals 10 minus 2 times 2, it will be 6 centimeter square per second, and this is the answer. Now we are going to solve another problem. A ladder of length 2.5 meters rests against a vertical wall with its upper end and rests on the ground with its lower end. جميل. Its upper end slides away. عايزين بس ايه how to imagine the position or the kind of movement of the rudder. Its upper end slides away from the ground at a rate of 0.6 meter per second. At what rate the ladder end moves on the ground when it's at a distance (1.5 meter from the wall). طيب جميل جدا. Let's move to the solution. This is the ground and this is the vertical wall, and we have now the ladder. As you see that we have, this is the length of the ladder 2.5 meters, and this is the distance from the wall meter, and this is y. As we know, by using Pythagoras, because this is 90 degrees, x squared plus y squared equals 2.5 squared. There is no x, this is 1.5, so 1.5 squared plus y squared equals 2.5 squared, so y squared equals 4, then y equals 2. Don't forget that x equals 1.5. Now again we have the same relation, x squared plus y squared equals 2.5 power 2, because this is a ladder and it will not change its length, so by differentiate to the time, 2x dx over dt plus 2y dy over dt equals 0. That means negative 2, because it decreases, multiply 1.5 dx over dt plus 2 times 2 times 0.6 equals 0. That means 3 dx over dt equals 2.4, then dx over dt will be 0.8 meter per second, and this is the answer. Okay, let's move to another problem. a man of height 180 centimeter walks with velocity six meter per second towards a light pool with a lamp hanged at its top. And of height 3 meters. Find the rate of a change of the length of man's shadow on the ground. Now we are going to solve, and we have to say that this is one of the most popular and famous problems that you can face in this lesson. Let's try to draw. This is the ground and this is the light pool of height 300 centimeter, and this is the man, and this is the lamp. Then that means y, this is the shadow, and this is the distance between the man, which is height 180. He said that the distance, the velocity of the man, the velocity means the distance, the speed that the man moves from the light pool, that means x. So x is a distance, that means dx over dt will be 6 meter per second. Then y, length of shadow, then from similarity why we use the similarity? Because we need to find out a relation between y and x, that we have y over y plus x equals 180 over 300. Y over y plus x equals 180 over 300, because they are parallel, by the way. So by making cross multiplication, that we will have the relation like that: 5y equals 3x plus 3y, we will get that 2y equals 3x. So y equals 3 over 2x. By differentiate according to the time, so dy over dt equals 3 over 2 dx over dt. By substitute dx over dt equals 6, then dy over dt equals 3 over 2 times 6 equals 9 meter per second, and this is the rate of a change of the man's shadow. By the end of this problem, we have finished our presentation about the related time rate. I think it's one of the most important lessons in our curriculum this year, but we have to solve more and more examples to make a good recovering about this lesson. أتمنى نكون إن شاء الله إن احنا استفدنا، ونترككم في رعاية الله، والسلام عليكم ورحمة الله وبركاته.